Yeah, someone should be watching the stream to make sure this stuff is going.
I don't have anything to watch.
Yeah, we definitely need to.
Hello and welcome back to Calculus 2. This is exam 1 review because in your infinite wisdom you picked to have exam when you had the choice not to have the exam, but this is only happening in my class. I give the choice not to have the exam and then you just like, no, we want the exam. And then you want the 7 quizzes on top of that. What's wrong with you? to start the stream with that. Okay. So chapters. Why is this red now? Chapters 6 and 7. We did do 8.1, but that's methods of integration, and that should just help for help on this test. So you're looking at 10 problems, hour 20 minutes. There's going to be a 5-minute break or so it's like 1:25. That's okay. And we are going to
use our phone?
have the problems. What happened?
Are we allowed to use our phones in the 5-minute break?
The phones. Unfortunately, no. It's the school policy. So no graphing calculators. That's the policy. You can bring any other calculator. So no phones, no tablets, no laptops, and so on. They never said anything about supercomputing clusters, so I guess that might be okay if you have an access. I mean, they never said that. They're adamant about the graphing calculator, but they never said anything about, if you have some kind of AI at home, like something equivalent to a Terminator that can solve these things, just bring it in. I guess I don't know. It's on paper. Every other page will be, so the exam is printed only on one side, not to waste the paper, but to give you the scrap paper on the every other side. So just make sure that you mark stuff that you want to be looked at. I don't look at those pages unless you said look at those pages. So if you, have to do problem number 5 from scratch, you just say, okay, add the back page here or there or whatever, and I'll eventually find it. So that's that. 10 problems. Each one should be 10 points, so it's easy. So we have chapter 6. Area between two curves. We have disk plus washer. So disk is 1 function, washer is 2. We have shell. We have length of curves. We have surface area. We have physics, which breaks into mass, which breaks into spring, which was the work, which breaks into lifting, which is also work, and finally breaks into the pumping. We ran out of time in class to do the last part of that lecture, which was pressure. So I can't really put that on because we technically didn't do any examples. Unless you want it, then I can add. But I don't see any takers, so let's go to chapter 7. In chapter 7, you only have 3 sections. First section is on derivative and integrals of logs and exponentials. Second lecture was on exponential models, i.e. word problems. And the last one was on hyperbolic functions, which includes algebra, identities, limits, derivatives, and integrals. Right, so we have algebra, identities, limits, derivatives, and integrals. And that's the exam. So you have what? 3, 5, 9 sections. You have to know the formulas, because you did not learn any new methods of integration. You did not learn any new methods for derivatives or limits. You learned no new calculus, technically. What you learned is formulas that work in the calculus realm to compute areas, volumes, lengths of curves, and then mass and these kind of things. This was the application: washer, shell, length of curve, surface area, mass, spring, lifting, pumping. That's 10 formulas. Derivatives of log and exponentials, so that's another 2, that's 12 formulas. Exponential models, you have another formula, that's 13. And then in hyperbolic functions, we said you know those sine and cosine derivative functions in respect to E, right? Definition. So that's up to 15 now. And then you have the 6 derivative and 6 integral formulas for, so 6 derivative and 6 integral formulas for derivatives and integrals of these. So on a paper, it's like, wow, 30 formulas for the test, and I have to memorize them all. Yeah, that's it. There's nothing else, right? There's nothing else for this test. Other than that, so those formulas are necessary. They will show up later. So mass calculation is going to be back in Calc 3 if you're going to Calc 3. Obviously, everything else is going to show up in physics and engineering. So yeah, that's great. Now, the exam is about hour and 20. So, hour and 20 is 80 minutes. So you are budgeting 8 minutes per problem. Please do not spend 37 minutes on the first example, right? And then you stare at the second example for the rest of the time. Skip around the basic. I'm not supposed to talk about test taking skills in Calc 2, but I am. Skip around, find the problems that you can do in literally 7 seconds. The idea is to have half of the test solved in the first 20 minutes, and then you can enjoy the other half of the test. So, yeah, the test is the learning. Yeah, what? You don't like showing off your math skills? That's what the exam is for. You come in, yeah, you come in, you show off your math skills. That's why I said enjoy. Okay. So the idea is to skip around and then see which problems, right? Some of you, naturally, didn't I talk about it the first day? We're not born equal, and we'll never be equal. Some of us do better with rotations. Some of us do better with length of curve. Some of us, right, do better with physics. Some of us do better with hyperbolic stuff. So whatever it is, find the stuff that you are very, very good at and do that first, so that you can spend the rest of the test less stressed that you haven't done anything yet because you are working on the first problem for 37 minutes already, right? So skip around and then come back and then keep checking. Devise some kind of a visual method, circling or crossing or checking off problem numbers or whatever, where you have to come back, what you have done, and so on. So so you can quickly go through that. So that's just the overview. And the question themselves, I don't know. I'm going to write it tomorrow because I still have the test. Is always Thursday, so I have time. Yes.
How are you going to fit all this in the 10 questions?
Easy. Why?
So you're just going to do like A, B, C, like for each one, like 3
No,
cards for each
no one said that all of this has to be on a test.
Oh. Okay.
So the disk and the washer method, right? Washer method is the one that is disk method is just f of x, right?
Yeah.
F of x.
Mm-hmm.
So the washer would be f of x squared minus 0, which is actually the washer. So disk and washer combines into one. And then see, deductive reasoning.
See, that's why, I want to hear, like, how you're going to...
What do I...
She wants to know what you're going to put on the test.
Oh, you want to know exactly what's on the test? Well, you have to email me then tomorrow when I finish the test so I can send you the test so you can take a look at it. You want to approve the questions? I had no clue. Can I actually have you write? Ooh, you know what we should try? You guys write it. How about you write a test?
Perfect.
And then
you take it.
And if I pass, no, then you split my grade evenly between all of you. So that's my 100 is actually I'm going to make up one mistake on the minus side. So my grade is 99 divided with the 33 of you. Right, everyone is getting a 3 plus 7. That's a clear 10 on the first test. I mean, come on.
You fail and we all pass. We fail. No?
Yeah, that's the problem.
That's not going to happen.
Okay, first problem.
Remember that I'm a ninja.
First problem.
Not yet. So I will fit this. I will fit this. I'm a professional. I've been doing this. The first class I ever taught was Calc2. So this is my longest standing experience. All right, Calc2. Been teaching it for years. Any questions, concerns on this list? Would you like me to add anything to the list? I'm sorry, addition and subtraction problem. Something like 13 plus 7, right? Is that what you're thinking?
So good.
That would be amazing. Okay,
Watch me
we'll
mess
work.
that up inside of
Yeah, that's what I'm talking. I put as a problem 11. 11 plus 17. If you mess this up, it's a 0 on the test, regardless of the other 10 problems. Good. Extra credit. Yeah, my exams have no extra credit ever, and there are no retakes afterwards. So I hope you did those quizzes. Otherwise,
you just find out who didn't.
You're going to have that problem at the end that we can swap, right?
that depends on the spice level of the exam. So if there are more than 1 or 2 problems that are on the Holy Nightmare side, we can add one of those replacement questions. And the replacement question is just replacing any question on the exam. So some of you might not like number 4, some of you might not like number 7, right? So you can use that question to replace question you don't, because you might not be remembering what was the revolution formula. The other thing for please don't forget that 2 pi for revolution. That's one of the. I mean, yeah, I know it's only like -1 or -2 depending on the mood, but just forgetting 2 pi
So
is
all the
devastating.
questions are evenly marked?
Yes, unless you would like to suggest something that it's easier than that. How about one question for 100 points and then we're just done?
Will you get credit if you remember
I don't get credit, I don't take it.
the formula?
Yes.
All right, then. I got 1 point.
You got
I got 1 point.
you got point per question already.
Do we have ECF?
Plus 7.
There you go.
Do we have ECF?
I'm sorry?
ECF?
ECF.
Error carried forward. It's like if you make a mistake in the beginning and you get like a wrong value. For example, if you had
Just don't make a mistake.
no, but if you had to
But
add,
don't.
we won't. But if you had to add,
Good. Then we don't have to talk about it.
Come on. Do we?
I think
don't
he
know
does.
what-
I think he does. Yeah, you do.
Like
Do what?
Just say, for instance, if you're doing your calculation and within it you forgot to carry the negative sign over and it should have been positive, so that means your answer is wrong.
Yes.
your
But
working
you-
is right.
You actually started it
Oh,
correctly.
you're asking if there's partial credit for questions?
Yeah.
Yes.
Yeah.
Yeah.
Yeah. He
Yeah,
always
that-
says
Is that okay with everyone? Or it would be better to just be right or wrong?
that. No. Angela.
You or die, baby.
Someone is getting a special exam over here. How about I pick the cheapest problem from each section and we just do right or wrong?
That's it. Done.
Problem number 3 from every section. And if it's right, it's 100% no partial credit.
Why is nobody going?
Problem number 3. What?
No? You just voted no on that?
Wait. Problem number
Wow.
3 from the homework. From the homework.
No, from the book, but that's, you already voted no.
No, it's fine.
No, I'll do it. Problem number 3 from all the
A
homework.
lot of people said no already, so you lost. I offered a specific problem. I said problem number 3. You could have just looked it up and just said, okay, here are number 3s from all sections. I'm ready. Anyway, all right. So we have a bunch of questions, which is great. Thank you for providing. Did you guys say thank you? Terrible.
You're welcome.
I'll go through these until I get bored and just gonna leave. I'm just kidding. All right, so let's talk about some of these review questions. These all come from your homework. You can find 100% of these questions in the study plan. Study plan will allow you to go to any section, including Calc 1 if you need to review U sub or limits. Or, as you see, the first question here, L'Hopital's rule, right? So this question says, figure out the limit as x goes to infinity of 2 minus 2 cotangent hyperbolic 6x divided by 5 minus 5 tangent hyperbolic 6x. And they say use L'Hopital's rule. Well, technically, is this a limit question? Yes, it is. But L'Hopital's rule has what? Derivatives. Very good. Right, so we are supposed to use the derivative to figure this out. Okay, I think we can deal with that. Would you please help me with these formulas? So the derivative of cotangent hyperbolic is negative
Cosecant.
squared, right?
Squared.
Hyperbolic. So cotangent hyperbolic x, I'm not going to use, well, I can put a. Nah, I'm just going to do the vanilla one. Cotangent hyperbolic x would have a negative cosecant hyperbolic squared x, and the derivative of tangent hyperbolic x would have, very good, secant hyperbolic squared x. So we know that, hopefully, in Calc 1, it's either, I think it's 4.8 section, you learn that if you have the limit of f of x over g of x, and you get the form of 0 divided by 0 or infinity divided by infinity, you are allowed to take the independent derivatives of f and g. So it's not a quotient rule, it's not any of those. It's just derivative of f separate from derivative of g, and then look at those if it's easier to do the problem. So by L'Hopital's rule, you put this L apostrophe H on the line, you get f prime of x divided by g prime of x. So now, this will allow me to go and say limit x goes to infinity, and now I have the derivatives. So derivative of 2 is 0. You copy negative 2, which is a constant. Derivative of cotangent 6, hyperbolic 6x is going to be 6 in front, and then we have negative, which will kill the minus sign in front, cosecant hyperbolic squared 6x. Denominator, 5 is gone. We are going to copy the negative 5. The 6 goes in front. Minus sign is surviving because this is just a secant hyperbolic squared 6x. These 6's will cancel, and what I have here is negative 2/5 fraction times, and oh, I forgot the limit. That's like -1 per line. Yeah, don't forget, it triggers my allergies. That too. So negative 2/5. Now, if you studied, you know that the cosecant hyperbolic is 1 over sine hyperbolic, squared in this case, and the secant is 1 over cosine hyperbolic squared x. So now you have 1 over sine hyperbolic divided by 1 over cosine squared hyperbolic. This turns out to be cosine hyperbolic squared 6x divided by sine hyperbolic squared 6x. Now that you can kick this negative 2/5 in front of the limit. So it's a rule of limits. And cosine over sine is cotangent hyperbolic squared of 6x. Good. Now what? Yeah, the limit. So what's cotangent hyperbolic?
1 over 10.
Yeah, 1 over 10. Yeah, sure. But you can also leave it as cotangent hyperbolic.
You're going to take another derivative?
No, there's no more derivatives needed over here. We could do that. Would that make you happy?
No, just leave it like that.
Yeah, let's write it in terms of E.
Can we just put a smiley face next to it?
Yes. So I have limit x goes to infinity, and now the cotangent, well, we have it here, so it's e to the x plus e to the minus x over e to the x minus e to the minus x. The 2's canceled, and the whole thing over here needs to be squared.
Wouldn't it be 6x?
That's what I said, 6x, please pay attention. It's clearly a 6x. You can see the 6, right? Do you see 6?
Yep.
Perfect. So it's clearly a 6x on each one. So what happens as I put infinities everywhere? The e to the minus 6x, they go to 0. And what happens to the other ones?
1. Infinity.
1, so? Whee! Cool, right?
The answer?
Why, disappointed? The next one is our cylindrical tank. We have a cylindrical tank that is 12 meters tall and 2 meters in a radius. And it's a water tank. Now, if they tell you that it's a water tank, then you know that your rho is 1,000. They actually give you that. Nice. They give you rho, 1,000 kilograms per meter cube. Nice. They tell you to use G, 9.8 meters per second squared. You are pumping the water to level 2 meters above. So your nozzle, now I'm going to put 12 meters here, and I'm going to install the nozzle over here. And the nozzle is at 14 meters. And what is the tank is full. Oh no, it's half full, sorry, half full. So the level of water is 6 meters. Nice. I am supposed to pump out those 6 meters. Okay. Let's go. Work is integral A to B of what? Rho G A of y times d of y dy. The limits are 0 to 6 because that's the amount of water that I'm pumping out. I only have 6 meters of water inside the tank. Rho is 1,000, 9.8 on G. Area of the cross section is 4 pi. Right, that's your A. Because its radius is 2. And for D, what do we do for D? Very good. So we have to pump at the level of 14 meters. So 14 minus y.
What's the area of the cylinder?
No, the area of the cross section, it's a circle, right? So area of the circle is r squared pi. Your radius is 2, so 2 squared. This is the problem where the cross section area doesn't change, so we don't need the function y. I mean the variable y. We have 9,800 times 4 pi in front of the integral 0 to 6. And all I need to integrate over here is 14 minus y dy, which is equal to a number, so we can move on. You integrate 14, you get 14y. You integrate y to get y squared over 2. You plug in 0 and 6 and... Yeah. Good. An adult consumes an espresso. I don't consume espresso. I was actually tricked once into drinking the thing with 2 espressos in it. This is me with no caffeine in 2019. Can you imagine what happens if I drink a beverage with 2 shots in it? I did not sleep a week. And I was very productive. So, apparently an adult consumes an espresso containing 55 milligrams of caffeine. I know some of you are resilient to this, like it's nothing. If the caffeine has the half-life of 6.5 hours, when the amount of caffeine in the bloodstream is equal to 20 milligrams. What'd you say?
I swear to God, I thought I heard you say cocaine. It's caffeine.
Caffeine, yeah. No cocaine. Caffeine. You get cocaine shot when you go to the dentist, but they don't call it that. They call it something else, but it's that. No, yeah, they call it Novocaine. Novocaine, yeah. Yeah, it's the family. So if your supply runs out, you know where to go. No, judging by the prices, I mean, you're probably on insurance. Okay, so create an external model for the given situation. Use the exact value for k in this function. Great. All right. Later on in this course, we are going to have a chapter on differential equations, and we will learn how to actually create this formula from scratch. You are supposed to memorize exponential formula in the chapter 7, which is given as y equals a e to the kt. So this is just a generic math boring formula. Right, generic formula. If your k is negative, so k less than 0, you have decay, and that's where our half-life problems live. And if your k is larger than 0, you have growth, which is where usually population, money in the account, and stuff like that lives. Charging the battery, let's say, charging the capacitor for electrical engineers. That would be the positive k in these problems. Now, since we are talking about the mass and the loss of mass, does anyone have duct tape or some kind of thing like that? Now, I'm not asking you for the rest of the gear, I'm just asking for that one piece. No? Because this is really annoying, and I keep hitting. So I just need something to like glue it down to the Scotch tape. Toss it here, I will catch it. Great. This is going to work because it's way too cute. Look at that.
I'm trying to avoid questions.
Yeah, there you go.
You're a piece of gum. See, I don't think.
Yeah.
This is actually so good that I can't break it apart. Perfect. Thank you very much. How are your sports skills?
Oh.
It's what we call cut-off baseball.
Cut off a bit? I wouldn't know. I just know that do they use those bats to like chase each other in the field?
No.
I've never seen the game, so I wouldn't know.
You're thinking of Quidditch and they do that on volleyball.
I wouldn't know, but send me the link. How I should.
That's Harry Potter.
So m is equal to capital M e to the kt is the model that would be using mass. So this would be the mass exponential model. Lowercase m is the mass at any time, and the capital M is the initial mass. And we said that the half-life is a time, so half-life lambda is the time when the mass is half of the initial mass. So now I can use the mass is half of the mass, E to the K, and then I put 6.5 hours as time. So that would be your lambda. And from this calculation, because these m's will drop, you can calculate K. So it's a very quick calculation, and this is a problem from pre-calculus, right?
Mm-hmm.
So what is K from this calculation? You ln both sides, and you ln this side, you ln this side, that kills E, and then you divide by 6.5. So what do we have? You said negative
9.48 hours.
I need 4 decimals on this, so K equals
negative 0.1066.
What, you guys want to go outside, work it out, and then come back? Or we're going to come to consensus over here who can use the calculator? I just need ln of 0.5 with a closed parenthesis after that. So ln 0.5, close the parenthesis, and then divide by 6.5. Well, are you using iPhone? Because it doesn't count. If you're using iPhone, they can't compute.
Negative 0.1066.
Aha! That's right. It's right there.
Negative
Yes.
0.1066.
6.6. Yes.
And
Good.
The T is 9.4.
So now, when I have K, I have a mathematical model for the dispersion or consumption of caffeine in bloodstream. Or so that's going to be E to the negative 0.1066 T. What did you say?
Didn't the question say that you should use the exact value?
You can't because you infinitely many decimals. I don't know what that means.
Where did the 55 milligrams and the 20?
That's the next part.
Okay,
So now, they're interested if you consume 55 milligrams, that would be your initial amount that you have. So I'm just going to box this as the equation that we are using. So this is our math model. And now they say when the amount that is left is going to be 20 if you consumed 55. So when is going to be 20 if I consume 55, and then here's the rest of the function. T is in hours. Please remember that. T is in hours because the problem says that the half-life is in hours, so immediately all other time variables in this problem will be in hours.
I have a question.
Yes.
In the midterm, if we forget to write like in the end like hours or meter squared,
It's a 1 point, but don't forget. Why would you forget? We're talking about serious stuff over here.
Okay. Oh, you want us to plug it in?
So I'm trying to get to the calculator. My calculator is working. Great. So 20 divided by 55, there has to be a ln in front of that. It's going to be negative 0.1066 t. So t is equal to ln of 20 over 55 divided by negative 0.1066, and that is what?
9.4.
How much?
9.4.
9 hours?
0.48.
9.4, about 9.5, 9.5 hours. How do I call it 9.5 hours? About. Boom, there we go. Squiggly equal over here.
9.5 hours. Oh, you did put it. I'm sorry.
0.95?
No. It's 9.
Because you need you need to go 6.5 hours to lose half of what you have, right? So if you're starting with a 55 and you wait 6.5 hours, you would be down to 27.5 milligrams, right? And then apparently additional 3 hours will drop you down to 20. So it makes sense to have 9.5 hours in this one. So, do you get to drink more than 1 espresso a day?
Espresso is way more than 55 milligrams.
Is it?
Yeah, that's like 2 cans of soda.
This is just a regular cup of coffee. They didn't say espresso.
Did it say espresso?
They did?
An adult consumes an espresso containing 55 milligrams of coffee?
Oh, that's just a Dunkin' Donuts coffee.
Next problem. This is why you love this class, right? You learn a lot of stuff.
That's weak coffees.
So wait, do they pack more caffeine in Starbucks because it's very expensive, or no?
Actually, Starbucks is a little bit more, tastes like burnt coffee. It's stronger. Yeah.
Okay, so is there anything that is good? Because all I hear is the first world problems over here. Wawa coffee?
Yeah, well,
So, are you just getting like a negative K? Or because I got like a positive when I LNs, I got like a positive point.
Honestly, like 4 days.
no, it should be negative.
Well, okay, so guys, there is a very important question. You can run this formula also with a negative K here. But if your negative is worked in the formula, then this K would work out to be positive. Okay? Because you already have negative in the formula. The important thing is that for decay problems, you must have a negative number here because that means you are losing stuff. Right? So I don't care if you start with a minus here and then you end up with this being positive, but when you plug it in it becomes negative, or you keep it as a positive K which gets in calculation to be negative. Whichever method you go for, the important thing is to have your number at the end to have a negative value here. And then that would guarantee that the amount is going down.
So if you don't get a negative number, just put like a minus sign.
It has to be negative.
Yeah, that's cool.
All right, let's see the next question. Oh, look at this. This is what I wanted the whole day. No. The derivative of cosine of x to the 5 sine 5x, is it?
Oh, that was my favorite one. Yeah.
This was on the first test.
Yep.
This is the spice level 5
Out of what?
out of 6.
Oh.
Yes.
So nice.
Because we can make this worse by putting a square over here.
Oh, no.
No? Okay, I'm just listing the possibilities. This is a completely useless question, right? It's just mathematical gymnastics. Therefore, it's to be used during the Thanksgiving dinner or something, right? Go out on a date. Drop this in as, by the way, kind of line, you know? It will guarantee you will die alone with cats or dogs.
So we should expect to see this on Thanksgiving, not on the test?
So now, apparently, we're coming in for Thanksgiving. Oh, wait, this is a spring semester. Are you planning on...
We're taking this twice.
Because I am teaching this next semester again, but that's when the Thanksgiving is. Unless we move the Thanksgiving forward. All right, guys. What I see here is a chain rule, right?
Inside of a chain.
And it's another chain rule. So this is a problem that has a double chain rule, nested chain rule. And the only concern that I have with this problem, all I need to do is to come up with a derivative of the inside. But that's a spicy one, right? So we have to use a logarithmic differentiation from Calc 1 to just deal with that And then when we get that piece, we will just insert that into negative sign and walk away. Be done, right? So, in, let's say, green, we are going to work on the derivative of the function y equals x, leave some space, to the 5 sine 5x. Now, the formula, when this x over here is a number, is provided to you in a lecture, and we know it's easy, right? You just know that formula. But when it's x, you are supposed to know that from Calc 1. So I'm a little bit surprised that this question is a part of your Calc 2 homework and stuff, because this is Calc 1 question from logarithmic differentiation. That's where it belongs. To solve this problem, you will ln both sides, because that's the only way to get rid of this exponent, because you have function raised to the function. So the only way to get rid of that exponent as a function is to put ln in front, but if you ln right side, you have to ln left side. So now you have ln y is equal to 5 sine 5x. Who came up with a 5? It's the same as s. It's just, and then times ln x. Right? So this is our thing. And now we differentiate the entire line. So over here we get 1 over y dy dx is a chain rule equal to, on the right hand side we have a basic product rule. I told you this is Calc 1. So copy the first times derivative of the second plus copy the second times derivative of the first, which is 25 cosine of 5x. Now, we know what y is this mess here. So that's going to go to the right. We have x to the 5 sine 5x times, in parentheses, we have 5 sine 5x divided by x plus 25 ln x times cosine 5x. Nice. So there is the derivative. This is the derivative of the inside. And now, to go back to my original problem, I'm going to go back to black color. So this is your work in the margin of the book, right? What happened? See this 1 over y? Became a y on this side. And we know that's your y, right? Mm-hmm. So now, when I'm taking the derivative of this, the derivative of cosine is negative sine. And then all I need to do is to drop this in parentheses. So x 5 sine 5x. No, I lied. No. You take sine x of this times this. So x to the 5 sine 5x times x to the 5 sine 5x 5 sine 5x divided by x plus 25 ln x cosine 5. There we go. Beautiful. You box this. It's a conversation starter. Or this is actually this is good for that situation. Ah, what do you know?
The conversation ender.
Great question. The line provided in my MATLAB is not long enough, I see. I guess you have to use a smaller font to to fit this, like 2.5 or something. Compute the following derivative using the method of your choice. How about my method is skip? Nah, this one is easy.
Okay, you can skip it then.
What happened? Yeah, just that. It's math. It's simple. You only have one choice.
Can you give us that formula of when it's a number? What is
The formula when it's a number?
isn't it like f prime of x plus
Yes. I'm going to write it down and then I'm going to erase it. So get ready. So if you are taking the derivative of a b, that's a number, like 2 or something, to f of x. This was given in a class. You copy it, so Control C, Control V, times f prime of x times ln b.
There's one for...
That's when it looks like this, 2 to the sine of x, let's say. Right, when this is a number. But now we also have a function, so it's going to be another logarithmic differentiation. Anytime when you have the derivative of f of x raised to the g of x, you have to use logarithmic differentiation. If you have a number raised to a function, then you are using this formula quick. Yes?
There was another formula for a function raised to a function as well. Can we just like learn that in this?
If you want to. Why would you go with extra stuff if you can just use the Calc 1 that you already know? But then, you are running your life. Just get the right answer. So I have y is equal to 1 over 2x raised to the 3x. ln both sides and be done quickly. So ln y is equal to 3x. You peel it off. ln of 1 over 2x. And then hit this with the derivative. You get that 1 over... It's a very structured step by step. You hit it with the ln so that your exponent can jump in front of that ln. It creates a product rule on the right side when you do the derivative and you're done. So it becomes, again, the derivative of ln y is 1 over y, followed with dy dx, which is a chain rule. On the right-hand side, you have the product rule. Copy the first times the derivative of the second. Now what? Nice. That's the boss move right there. You see this one over here? The ln of 1 over 2x is ln 1 minus ln 2x. ln 1 is 0. So the whole thing is just negative ln 2x. So you are taking the derivative of this, actually. So what's the derivative of that? Is negative. You copy the function as is on the bottom and put its derivative on top. So it's just negative 1 over x. Nice. Plus, copy the function. We can copy this one, negative ln 2x, times derivative of the first, which is just 3. dy dx is equal to, plug in y. Y is 1 over 2x raised to the 3x. So that's me carrying this y to the other side. And now we have these two die. X is die, so it's just negative 3. Nice. Minus 3 ln 2x. This is great. Done. Move along. Thank you for providing these amazing
Can you explain the last one?
I'm sorry?
Can you explain the last one?
This one?
Yeah.
We have the 2 canceling, and then x and x canceling.
Mm-hmm.
So all it's left is -3.
Yeah.
And then just this 3 goes in here, and that's it. Okay, we finally hit the question that I would definitely put on a test if I was any kind of authority here. And that is prove that the integral of cotangent hyperbolic x dx is
Everybody said, oh shit.
ln of sine hyperbolic x plus c. This plus c is a point. What should we do? Skip? Yes. So we are going to rewrite this as cosine hyperbolic x divided by sine hyperbolic x dx, and then just run basic u sub. So u is equal to sine hyperbolic x, du is going to be cosine hyperbolic x dx, and the entire problem breaks into, very good, 1 over u du, which is ln absolute u plus c, which is ln of sine hyperbolic x plus c. What a cute calculation.
How did you know to put that over?
Cotangent is given as a cosine over sine. Tangent is sine hyperbolic over cosine hyperbolic. So, how do they know? Years of experience. No, actually, I had help, so I just chill. Yeah, we're not going home. Oh, pick out this question and see. We did these. Looks like 6 questions left in this poll. All right, moving right along. How about some rotations?
Yeah.
Do the disk method around y, do the shell method around x for the same question. That's what you had on lab. This would be an amazing question for a test because you get to do both and then match the same answer. And I learned not to put that on a test very quickly because when you can't match the second answer, you waste all of the time. So the grades are like 17 because you only did the one and something else in the problem. So the region R in the first quadrant bounded by the parabola y equals 16 minus x squared is revolved around y-axis to produce a dome-shaped solid. All right, we can graph that real quick. So here is the parabola that goes through 16. It should hit the x-axis at 4, right? And we are rotating this around y-axis to create a dome. Great. Find the volume. Okay, I will. So what is the natural thing to do first? Clearly shell method. Shell method would be the best because when your dx or dy needs to be parallel with the axis of rotation. In this case, we're rotating around y-axis, so dx would be our representative rectangle, and I will be using shell. So volume is 2 pi integral 0 to 4 of x, and then I have 16 minus x squared dx. So it's p times the age, right, times the height. So the height is this, and it's a very quick problem. So I have 2 pi integral 0 to 4, and I'm integrating 16x minus x cubed dx, which gives us 2 pi, this is x squared, so 8x squared, minus x to the 4 over 4, calculated from 0 to 4. 2 pi, 8 times 16, minus, and over here I have 4 to the 4, so that's gonna be 4 times 16, because I have 4 4s on the top, one gets cancelled, I take 2 for 16, okay, good. I just don't want to use calculator because, and I have a 2 pi, so that's 8, 16, minus 4 over 16 is 4, that's 16, which is now 4 times 2 is 8 pi, and the 16 is 8 times 2, so 8 times 8 is 64, 128 pi. All right, good, yay.
Can you go over how you decided to go with the shell?
He had to do both.
I have to do both, but I wanted to do shell first because it's easier, because I don't have to convert functions. I looked where, that my rotation is on y-axis, and I wanted dx, so it's a shell because they're parallel, but now I have to do the disk, so...
In the end of the class, can you go over when, like, a certain method won't work?
Well, why couldn't you use wash? What tells you?
No, wash when you have two functions. Now we're going to use disk. So now it's the same question, guys, and I have to get the same answer. But now the annoyance is that we have to use dy. Yes, we have to convert. So now our function is y equals 16 minus x squared. So that means that the x squared is equal to 16 minus y. And then x is equal to plus minus square root, but we drop the minus because we are only in the first quadrant. So square root of 16 minus y. And now the volume is pi, only pi, integral from 0 to 16, and I have my square root of 16 minus y squared dy, because it's just f of y squared for this one. So pi 0 to 16, the square root will kill the square will kill the square root, and we just have the basic integration now. So pi, that's 16y minus y squared over 2 from 0 to 16. So what do I have? I have pi. I have 16 times, well, that's a 16 squared, minus 16 squared over 2. Zeros we don't worry about. So this is now equal to, if you regard 16 squared as 1, so you have 1 minus a half. So that's just 16 squared over 2. Now, to quickly compute this, you don't go and square 16. You write 16 as 16 times 16 over 2, and then this cancels to 8. And then you write this 16 as 2 times 8 times 8. So pi times, this 16 is 2 times 8 times 8. So 8 times 8 is 64 times 2, 128 pi. There we go. Really? It's just a quick calculation rather than chasing the calculator. Or you can just take the calculator right here and just get it.
Yeah.
Yeah. Yes. That's for the inside, for the height. The front one is X unless it's...
Yeah, so like if it moves from y equals 1 to 16, it'd be the function minus 1.
Yes. These are some great questions.
Thank you.
Here's this one.
I tried my best.
So when it's parallel like that, it's a single pi instead of 2 pi?
This is perpendicular.
Or,
Yes. Yes, the disk method has a single pi, the shell has 2 pi. Your rotation for a surface area in 6.6, I think, also 2 pi. So that's the formulas. Physics. How about some springs?
Yay, spring.
Yeah, exactly. A spring on a horizontal surface can be stretched and held at 0.4 meters from its equilibrium position using the force of 44 newtons. This is a spring problem, and I am going to draw this spring over here and then add the crate. Add some weight on this side, right? So if this is the equilibrium point 0, move this 0.4 meters, right? Okay, so this is my distance delta x that I get to move, and we need to use the force of 44 newtons to do that. Hooke's law says what?
5.4 by 44.
The force is K delta x. The K is the spring constant. Delta x is the amount of stretch, and F is the amount of force that needs to be used to achieve that. So I have that F is 44 newtons, unknown K for this spring, and then 0.4. So K is going to be 44 divided by, we'll put 4 over 10, so that's 1110. So 110 newtons over meter for the spring constant. So now I need to calculate here in the problem how much work is done in stretching the spring 1.5 meters from its equilibrium position. Work done. I am starting at the equilibrium position. I am going all the way to 1.5 meters. And I am stretching the spring. So what do I put inside? What is work? Work is force times the distance. So my force is 110x, right? That's my force. And then dx. So now, integral of this, half of 110 is, very good. So we have 55x squared from 0 to 1.5. 55 times 1.5 squared, and that's equal a number, and there you go, done. Are we good? How about to compress the spring? To compress the spring, we need to get to negative 4 point. You can put the negative on top if you want, and then when you swap, the integral will go. It doesn't matter. 110x dx, and then you just, here, just do it. There's the... All right, good. Next question.
It took me a second to realize why you did that. It was the 90 switch.
Yes.
And I'm like,
Yeah, you got it. You got it. Find the arc length of the curve given by... this is given as y's. Like it. It doesn't matter if it's done.
Oh, yeah.
And now this is done too. So after this question, 3 to go. Nice. Yeah.
This is the one who's doing it.
Oh, yeah, I got that one.
Yeah, that's a clue.
No.
It came off.
Yeah. Does anyone have that the big clip or something? Give me your gum. Toolbox in a car, anyone with duct tape?
super glue in the car.
Super glue in the car. If anyone wants to come here and just hold this for the rest of the class, that's your job. Your job is to stand here
15
and just
points
hold.
on the exam. I'll do it.
No, it's not extra credit, because if I get annoyed, I don't have a good working conditions. That's what I was looking for. And you know what? I'm gonna keep the cute one underneath.
Yeah, definitely. That way you still get the style points.
There we go. Now I get to. Perfect. There we go. Thank you.
Yay. You said arc length, right?
Yes, arc length.
Okay, so that's going to be
Arc length formula, which you must memorize, a to b square root of 1 plus f derivative squared x dx. Now we get to use y's, so this is going to be c and d, and it's going to be y and dy. Doesn't matter. First order of business is to calculate our derivative f prime of y. Are you happy with your physics problems? You already had two? Okay. So we have our f prime of y is you copy the quarter, and then you have 4y to the 3, plus you copy your 1 over 8, and the derivative of y to the negative 2 is negative 2y to the negative 3. And now you fix this. So 4 and 4 drops, you just have y cubed, and then these guys cancel to a negative 1 over 4y cubed. Are we all okay with this algebra? Yes. Whatever I say, right? All right, fine. I like it. So now we do our length of the curve, 1 to 2, square root of 1 plus no coughing. We have y cubed minus 1 over 4y cubed, and you have to square this, and then we have dy. That's much better.
Oh, okay.
We all good?
Yes.
The only thing we can do here is to square the parenthesis. So integral 1 to 2 square root of 1 plus we have y to the 6, and now we have to multiply these two. The y cubed and y cubed cancel, and it's double, so it just becomes negative 1/2. And then plus 1 over 16y to the 6. We still have dy at the end. That's like -1 per line if you're not writing it. The only thing I can do here is add the 1 and the negative 1/2. So y to the 6 plus 1/2 plus 1 over 16y to the 6 dy. And now is the time for the trick of the century. As you're doing homework, did you ever wonder who figured this out?
Yeah.
Right?
Very lonely.
No, it's just there was no YouTube and to watch like little kittens fall and stuff like that. So you sit and you figure these things out. It was awesome. So y cubed plus 1 over 4y cubed squared dy, which is where the square root and the square annihilate each other. And we have integral 1 to 2 of y cubed plus 1 over 4y cubed dy. And all we need to do is to integrate this. So that's y to the 4 over 4 plus 1/4. And then this is y to the -2 over -2, calculated for 1 to 2. Y to the 4 over 4 minus 1 over 8y squared from 1 to 2. Plug in 2, 4, 8, 16 over 4, that's a 4. Minus, plug in another, that's a 4, that's a 32. Minus, plug in 1, that's a 1/4. And then plug in 1, that will be plus 1 over 8. So the common denominator over here is, I don't know what I'm doing, it's just, that's it, I'm done.
123 over 32.
How much?
123 over 32.
Thank you, that was excellent. Done.
Can you just go over quickly why that trick essentially works in this specific?
It works in every, not this specific.
The half.
You have this equals this when half is negative, right? So when you have the same with a positive half, it has to go into the same thing with a positive half. So you just foil it back.
But if you want to do that, you use
Yeah, yeah. So it's either going to be this trick or a U sub. You don't have any other choice. Great. Devise an exponential decay. Rejoice. There is another exponential decay function that fits the given data and answer a company question. Be sure to identify the reference point equals 0. The homicide rate decreases at the rate of 2% per year in a city that had 800 homicides. That makes sense because homicides make less population, so it will be less homicide every year because there's less population. That makes sense. No, you have to make sure that it's mathematically sound, and it is.
I thought you might enjoy that one.
Okay.
Oh, I didn't take a lift. I don't have a lifting drawing.
So, it's fine. So in 2009, we have 800 homicides. That's going to be our first point. They're asking, at this rate, when are we going to have 600, right? And the rate at which it decreases is 2% per year. Okay, what now?
I mean, not with this. It's simple enough.
Y to the t is that same formula.
Yeah.
Y to the t? What do you mean
Y
y?
equals A.
You take
Y equals a to the e to the t, yes.
Yeah, but
Y equals
To the KT.
you know.
e to the kt. Okay, does anyone remember from your pre-calculus the money equation for continuous compounding?
Didn't you forget your A?
No. Fair. Does anyone remember that the amount was the principal e to the rt when r was the percent of your?
Also,
So aren't we just going to put down negative point, right, for the decay?
yeah.
Yeah, boss move, right?
Yeah, there you go.
So
Y equals negative 0.02.
good. Okay. So the first order of business is to understand that my k is going to be negative 0.02 because that's given to us. So my homicide model is y equals a e to the negative 0.02 t t in years. Now I need to supply the year, and I need to supply the So we are first going to set t equals to 0 for 2009, which would make subsequent, if you have t equals to 5, that's 2014, right? So now, in 2009, y is equal to the, the homicides are 800. I mean, I should just write the model, but at least I can show you. That's fine. 0.02 times year is 0. So that makes this exponent to be 1. And then we have that a is equal to 800. So this is why I told you that anytime when you have your t variable to be 0, the y coordinate is immediately your initial value. So our homicide model is 800 e to the negative 0.02 t. And so we're going to say this is our math model. And we just need to plug in 600 for y to calculate when. Right now this t is going to come up to be
14.
Some kind of, 3, 4, 5, something like that.
14.3.
14.3, okay, great.
So it could only be 14.
So it's 600 equals to 800 e to the negative 0.2 t. And then you divide 600 by 800, kill all the zeros, is e to the negative 0.02 t. Then you ln both sides. That kills e. And when you go all through this calculation, you said you get 14 years.
14.38, yeah.
14.3 years to be more precise. So in March. Okay. Oh, sorry, April. So in April.
Yeah, but you have to find 2023, right?
Yes, so it's 2009 plus 14. It's going to be 2023.3, so in April. Wow, when you can be precise. What are we going to say? Going for a mayor? It's a useful thing to know.
I have a force question after.
Oh, force. I keep hearing forest, and it's like, what is the force? Okay.
Are we doing force? Are we doing?
Oh, this is your homicides. There you go. Ah, the mass.
Mass is easy.
Let's leave that.
Mass is easy.
I still want to write it. Can I write it?
All right.
So mass is the integral of density function. Thank you for allowing me to write this. So mass is integral in this question from 0 to 6 of 4 minus x over 6 dx, and then you just calculate.
What's hard in that?
Nothing.
It's called variety, and it's a physics problem, so we should have
I
that.
think we should have.
Yeah, and then I put the integral
I
from
don't have a lifting.
8.1.
Does anybody have a lifting? I couldn't find a lift.
Don't worry about it. Relax. You're not relaxed. No.
I was specifically gonna find it.
Hey, look at this. It's the surface area of revolution. Write the integral that gives the area a surface generated a curve revolving around the given axis. Use the calculator or software to approximate, so that means you will not be able to integrate this. But at least we can answer the part A, which is set it up.
Hmm? Oh, the homicide. Sorry.
What about the homicide?
Oh, the exponential. That's the homicide.
So y is equal to the tangent x, and your x is in between pi over 8 and pi over 4, and we are rotating around x-axis. So you are supposed to have area, or they call it as surface area of revolution. Don't forget 2 pi. We have integral of pi over 8 to pi over 4. And then what do we have inside? We have our function, which is tangent x, times the square root of 1 plus, and the derivative of tangent is? Very good. And we have to square it. And then dx. And all you need to do is to plug this in Mathematica and you're done.
This is the one I have.
Oh, one more. Ooh, that could be a question on the exam. Set up the formula. And we set the formula.
Who said that that's not already a question on the test?
That would be a cool question. He made it already. Bullshit. He's gonna do another one.
Yeah, don't worry about it. Don't worry about it.
Don't worry about it.
What does it look like? Let me see it.
It's a homework question.
Let me see it. Let me see it.
All right. All right, I guess bye.
I have a question.